Good morning. Today we will start with something new, like another field in physics, and we call it dynamics. Now, dynamics is now we are going to understand what is really the total or the net forces that acting on the object and cause the object to move. And here we are going to talk about something called force. Force is a vector quantity, of course. Its definition, it is a push or a pull. Now, in order for us to find out this is my main question, what is the net force, which is I will need, okay, then I need to draw something called a free body diagram. Then the key for any solution or to do anything related to the work in this chapter, it has to do with the free body diagram. That free body diagram is gonna illustrate, or it will show, let's say show diagram. Okay, it will show, okay, free body diagram shows the external forces acting on the object. And just here I underline here on. It is not by. Then that object, in the same way that there are things like I would say other objects acting on it by forces, but it also acts on other objects by forces. We are not interested in any force that is acted by this object, but we are interested in what are the forces on the object. Now, before we start with free body diagrams and start working on these, we are going to start with laws that we are going to study in this chapter, and they are all related to Mr. Isaac Newton. Then the first one, it is Newton's first law of motion. We're gonna just talk about the laws, and then we are going to move to the problem solving later. Now, Newton in his first law said a body at rest remains at rest, or if it is in motion, remains in motion at a constant velocity unless acted upon by a net external motion. And what is really important here to understand that here we have this notation is going to be used, and that means the sum of all the forces. And in the case of a Newton's first law, this equals 0. In addition, I will say we can split this into two equations, sigma fx equals 0 and sigma fy equals 0, because in this chapter we are going to have forces and we are talking about two-dimensional things, and we will be able to maybe split the, I would say, the forces into x and y and talk about each I will say dimension by itself. Now also in this chapter and the following, we need to differentiate between two things, mass and weight. Okay, now what is really the main thing that we are going to study here? Like in chemistry, you're treating mass and weight the same way. Now, in this chapter, no, we are really differentiating between mass and weight. Now, I'm gonna here have kind of a table that I'm gonna use to differentiate between mass and weight. Mass and weight. Now the mass, its definition, the amount of matter in the object. Then if you have a 5 kilogram aluminum thing, it has 5 kilograms of aluminum. Now the weight, it has to do with the force of, let's say, gravity on the object, or we can say the pull of the earth. Like if we are talking about mainly we are talking about our earth as our reference of frame. Now mass is measured in kilograms, kg, and it's a force, and therefore we will talk about this, of course. It is measured in newtons. I will say also that the mass is constant. I will say it is independent of your location. Here, it depends on your location. If you are on the moon, you have a different weight than you have on the earth. Now, the one thing also, this is a scalar quantity and this is a vector quantity. Finally, I want to tell you that weight equals mass times g, and g, something that is really very important, it is not gravity, it is acceleration due gravity. Okay, then this is really very important for us to understand these differences between weight and mass, because we are going to deal with them today. Going back to Newton's first law, because I need to talk maybe here, this is why I have introduced the mass, because I need to talk a little bit about its relation to mass. In Newton's, first law, sometimes we call it law of inertia. And the meaning of inertia, it is resistance to changes in motion. It has to do with what? It has to do with mass. Then, as the mass is growing, inertia is growing. It is hard to accelerate, or it is harder to accelerate an object that is having maybe 50 kilogram than when I have 1 kilogram. Okay, this is very important to understand and find out about, how really inertia it is controlling the motion. Then I will say it has to do with changes in motion. Okay, like it will create more resistance to motion. Now the other law that I'm going to introduce now, it is, and this is maybe most of the work we are going to do with the Newton's first and second law. In Newton's second law has to do with the Newton's first law. Of course, I can say in Newton's first law is a special case of in Newton's second law. Now, in Newton's first law has to do again with the net of forces, but it is telling us that there is a direct proportionality between acceleration and net force. Okay, then this is what is creating that acceleration. It has to do with the net of force. And I will say, if we double the net force, acceleration will double as well. Triple means triple. And this is really very important to understand that this is the relation that we are going to deal with during this chapter and the next chapter. I can say also sigma fx equals max and sigma fy equals may. And I think you can see that if I will say here that the acceleration is 0, which is the case with Newton's first law, this means that sigma f should be 0, which is in Newton's first law. There is, as I said, there is a direct proportionality between the acceleration and the net force, and there is an inverse proportionality between the mass and the acceleration. As we have more mass, of course, and this is, I will say, making sense, I'm going to have less acceleration, and if I will have more force, I should have more acceleration. Now, units of force, I will say sigma F equals m times a, then it is kilograms meters per second square. Appreciation for Mr. Newton, we did say that this is in Newton. It's going to be the unit that we are going to use for the force, or you can say kilograms meters per second square. Now, of course, I can apply that directly, or I will say sometimes I will use these, formulas, these equations in okay, then this is this is my main formula for a Newton's second law, but we might use also equations of constant acceleration motion together with these in this chapter. Equation of constant acceleration motion, and I will say these are V equals V final equals V initial plus AT, V final squared equals V initial squared plus to a delta x, I can say delta x is v initial times t plus 1/2 at squared times t. Okay, and as I said, for a complete solution and correct solution, we will draw free body diagrams. We will come to that. Just today, in this recording, I'm just here presenting for you the laws, and I will not solve maybe any problems in here, because we are going to have this in chapter 5, where we are going to have more of the problem solving. But here I'm presenting for you the laws, the major laws that we are going to use. In Newton's third law now, it is talking about action and reaction, and it's talking about whenever one body exerts a force on a second body, the first body experiences a force that is equal in magnitude, it's exactly the same, and opposite in direction to the force that it exerts. This is here, we will say we don't have no single force or forces in nature. Always occur in pairs. We call them action, reaction usually. And I will say, if I have these forces between two objects, let me show you, and regardless what are the masses, let's assume this is 1, this is 2, the force from 1 and 2 should equal negative the force from 2 and 1. Okay, this is what and the other one is this one. Equal in magnitude and opposite in directions. Now, one of the things that I want you to know, that they are equal in magnitude, opposite in direction. They grow together and die together, which means, I would say, no one can exist without the other. Now, they are acting on two different objects. As in the figure here, I said the first force, this one, acting on 2 and from 1, and the other one, it is acting on 1 from 2. Okay, now I will present here examples on forces. What are really the forces that we're going to expect? Because whenever we are going to draw free body diagrams, what we are going to do is we're going to have an object that is really in any scenario, that is on a table, moving, whatever. And we are going to ask you to draw free body diagrams. Then here, what I will say is we need to understand and find out what are really examples on forces. And usually I will start with weight. And remember, most of the time, the mass is going to be given to you. Then you are going to find the weight by using this formula. And here, the mass should be in kilogram. The weight is acting perpendicular to the ground, always. How? Of course, we, like any force, we represent it as a segment plus a row, a head, and that head is gonna be directed along where we are going to, have the direction. For example, here, if I have this object, the weight is this way. If I have my object on an inclined plane like this, it's gonna be this way. Or like here, you can say, or W. Okay, then always it is perpendicular to the ground. The second force, it is normal force. I use it for it capital N or uppercase N. This one, it is the force when you have your surface is actually in contact with the object. Then if you have two surfaces in contact, this is going to be the normal force. The normal force, it is called a contact force between two objects. For example, you have a table here and you have your textbook on here. Then there is the weight downward. There is a force that is actually, we call it the normal. And I will say normal means perpendicular, and this is normal to the surface. Which means if I have my object on an inclined plane now, they will not be what? They will not be opposite to each other anymore. Okay, then like the normal is perpendicular to the surface, and mg, it is this way. If we have the object in the air, we don't have any normal. Okay, then we don't have normal at all. Now, number 3. Let's assume here I have this, and okay, they have, let's say I'm pulling using a rope or a string. This is T, we call it tension. And the tension in the same rope, it is equal. Otherwise, it will break. Tension, usually whenever we have strings or ropes. Okay, and as I said, the tension is constant in any rope. What does that mean? Let me show you. For this one here, let's assume this one is T1. There is, of course, a tension in between the two, okay? And I will say this one is pulled by T2 in this direction, and the other object, it is pulled by that object with a T2 again. It's the same, but it is opposite in direction. Then this is, okay, also, whenever I have a pulley, you're gonna find like I have maybe two different masses here. I will have here T, and I will have T here. And we will change that maybe later when we talk about the rotation of a pulley. But for now, this is what we will use, like it's gonna be the same T. We will not talk too much about friction, but I'm gonna introduce here friction or air resistance as a force that opposes the motion. Then if you have your object moving to the right, okay, the friction is gonna be in this direction. But of course, we will talk more about forces of friction later in chapter 5. Now, I will go over what are really the steps for problem solving, and then I will start talking about problems related maybe to Newton's first law first, and then I will talk about other examples later. Okay, then here the first thing is we will talk about problem solving strategy. And simply, I will say the steps. It is the first one, and even if I did not ask for that, you should provide it, which is free body diagrams. The second one, you're going to apply Newton's laws. Sometimes you need to apply Newton's first law only, sometimes second, sometimes first and second, sometimes first and second and third. It depends. Now you are going to form equations. You're going to solve them and calculate your unknown. Okay, simply these are my steps, and I will show you. When I say solve them, you might have like I will say something like two simultaneous equations, or maybe three equations. You're gonna solve them together. Okay, and I will show you in a little bit how we are going to start talking about Newton's first law, and then moving to Newton's second law solutions and Newton's third law. Thank you, and see you in a little bit.